Hello, are you there? Hello, chat rate 1, concurrent viewers 0. Hmm. Hmm. 1 viewer, someone has joined. No one is still here yet. So, yeah. We wait first for a while. Hmm. No. Hmm. You're the first one. I don't know where is everyone. Okay, from last week one. You didn't come, but let's see if you can do it. Maybe you learned before. Right, very simple. Okay, so Zening, I'm going to open the question paper here. Okay, you can see it. Do you know how to do this?
Maybe.
Huh?
Maybe.
Okay. Try. One only. Zening, you put your answer in the chat.
Me?
No. I'm talking to other student. You write your answer in the chat. Just put 1A. What's the answer? Then if done, then I go to the next one for B. If you hear me, then say yes. Put the chat. Put in the chat. Hi. What's so funny?
Lesser and lesser people Now he's not here.
Yeah, I don't know. Oh. Do number one and number two.
The one I'll do.
Yeah. You don't wanna. You don't wanna. You don't wanna. You don't wanna. Nice nails. Really? Yeah.
Not bad.
Okay. Write your answers in the chat, man.
Are you also live streaming?
Yeah, I have to. For this kid. You kid. Come on. Number one, what's your answer? Come on. Write your answers in the chat. Which one is the loudest? You learn this or you don't know the answer? Huh? Wrong. Okay, from the previous lesson, we learned about the sound wave. Okay, so we have two things to consider, which is first is the amplitude. Okay, and then the second one is frequency. You learned this before?
I have forgotten.
Okay, so for example, you have a sound wave like this, and a sound wave like this. Okay, so this one is definitely higher. This one is a little bit shorter. So the height here refers to the amplitude, the height of the wave. So the height means this is same like volume 1. So here, this one has higher volume than this one. Okay, the next one you need to know is about frequency. So maybe two sound wave can have like the same amplitude, same height, but this one like have more waves into it. The amplitude is same, so it means the volume is same. But here This one is high frequency. Okay, this one is low frequency. The difference between low frequency and high frequency is how the pitch of the sound. For example, like if high frequency means high pitch means like you scream like that. Okay, that's high pitch, or like a bell, a whistle, that's high pitch. Low pitch is like drums. So
Why the answer is please?
yeah,
Why?
because the height is the biggest. We're talking about the loudest one. Loudest means like the volume one, right?
Okay.
Mm. Hi K, yes D, teacher I write a D. But your answer is wrong. It's not D. It's supposed to be B. That's the wave with the largest amplitude. Okay, then I scroll to the next one. I want you to do which of these will make the sound louder? Maybe I give you more space like this. Okay. Just type in your answers. What bruh? Teacher, I read Eddie. I read in the chat. Maybe got delay. I don't know. Delay for a few seconds. What? I can see a chat going in. Type in your answers. What bruh? What? Why? Why are you calling me?
Is there a word that describe? Do I have to write a word? Can I just describe it?
But what one? You then also where's your note?
My back.
Where's your bag? Oh, you don't have the note yet. Need to print. Why? Why are you screaming? Why are you screaming in the chat? Just why? What's happening? How late? This is live chat, man. Oh, 2 to 5 minutes late. Why? Layout finish, stop mine. Okay. Print. Print. Yeah?
What is this?
Sounds effect off. And then can energy, sound energy. Is it can? Okay. Let me see the previous one. From A to B, what happens is the loudness. Does the loudness decrease? Are you sure? The height looks the same, isn't it?
So the answer is steady.
I think it should stay the same, right? For this one, for number 2.
Oh, I not say the same.
For the loudness, it should stay the same, but the frequency is increased, right?
Okay.
For this one, which of this will make the sound louder? Increasing the amplitude. To make the pitch, increasing the frequency. Why you have this one? Tick plus cross. I print the note for you first. Okay, you can continue with this one, Zening. Continue with this. The back page is upside down, right?
Okay. It's a force, right?
Energy. Yeah, sound energy, right? So remember. Sound energy. Zening, I send the document to you in WhatsApp so you can take a look and it will be easier for you to just do from there, I think. Cannot because my grandma. What? What your grandma? You use your grandma phone. Oh. Then how Easier. Force, cancel, energy vibrate. Done already. Oh. Okay. To replace one note quietly and then makes this note louder and draw the system. No, but this one is definitely wrong. This one is wrong one.
Then what should I do?
First, it's not that loud, then it becomes louder. So what happens to the sound wave? Or what happens to the pattern?
Am I supposed to draw a lot of sound waves?
Yeah. First, it's not that loud, but then it gets louder. Something like that. Loudness, something like this. You should draw something like this. But this one is from loud to more quiet. Loudness between X and Y, decrease. Amplitude, decrease. Pitch. Yeah. Stay the same. I think it should stay the same.
Still got 4.
Yeah. 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 The bigger the vibration of air particle, the quieter the sound falls. Sound wave can move through air. Vacuum, sound wave cannot move through vacuum.
Yeah, that's what I thought. See, it deleted it.
Then
Then I thought it could,
Then
so I added through.
when there is no sound, the particles stop moving. When there is no sound, the particles stop moving. Huh? When there is no sound, the particles stop moving.
Because there's no particles to move. So it's not
No, it will still move. Even if it's silent. A high pitched sound is always loud falls. Particles are closer together in compression than a rarefaction. What even is that?
Oh.
2018 rarefaction. Compression and rarefaction, High pitched sound is always loud falls. So you need to change for number 3 and 4 and also 3, 4 here and also this one. No answer? This one starting got, then this one also got, but then after a while it combines together, it becomes nothing. So this one we call it a cancel lah, the sound waves are cancelled. Okay. So you note also. Um, and then okay. And V vibrate, has high pitch, B loudest, you see this one. Here this person plays one note quietly and then makes the note louder. Okay. So it means first it should look something like it will look something like something like this. But this one is from loud to more quiet. But now it's opposite. It's from quiet to loud. So how would it look like? You don't have eraser
No. You can tell the difference.
What do you mean?
The difference.
There you go. And check in. Okay. I scroll to the next one. Okay, now this one. What?
What?
What? What?
Is it predict the speed of sound too? Okay. Water should be slower than air, right?
No, it's faster.
Why?
Because for sound to travel, you need vibration of particles. When the particles are closer to each other, like in solid or in liquid, then it means the sound will travel quicker because the vibration is like more instant.
But then if you go underwater and then you talk to people, right, you can't hear what they're talking about.
Yeah, maybe because your ear is not adapted to like hearing underwater maybe. But it should be faster. It should be faster. You got try before, like you put your ear on the table, then someone bang from there.
Yeah.
Sounds very clear also. It's quicker. It's quicker. For your answer in this one, Zening, with 3 and 4, they cancel each other immediately. Okay, it becomes a flat line. So you just need to say that the sound wave will be like cancelled. Okay, this is the next one. They ask you to predict only.
Predict lah.
Yeah, they don't need to be that accurate. Pure water, we will expect water will be at least a little bit faster than air, right? 1,000 I think is okay. You put how much? 6,000? 6,000. I think it shouldn't be more than glass or aluminium. Because glass and aluminium, it must be must be faster than water one because they are solid. Okay, solid will travel the fastest one. So it must be in between air and aluminium, somewhere around that. Okay, so maybe it should be below 2,000 but more than 500. So 600, 1,000 is okay lah. Okay. Why sound travels quicker through glass than through air? Because sound travels faster through particles. The absorbed by the material. Huh? Really?
I don't know.
How sound
I'm
travels?
yapping, bro.
You search What's the reason? It has something to do about vibration for this one.
What's the answer?
Try and search. It must have the word vibration one. Okay. Particles and vibration. I give you the keyword. Find something relating to vibration and particles.
My one cannot be correct one meh?
Nah.
Why?
Nah.
Why?
Because nah. A vacuum does not have particles for them to travel because the production of sound relies on vibration of something, of particles. In vacuum there's no particles to even like vibrate.
Yeah, exactly. There's no particle to vibrate, to travel.
Not to travel but to vibrate.
Same thing.
Nah.
This is correct.
Sound when object cause movement. Yes. And when object vibrates, that one's okay. Just the highlighted part. Next we will continue with the last week topic. it's quite hard to do questions in this format, I think, because someone is doing online.
Which one is wrong?
This one, how sound travels through a material. You can just say the particles vibrate. Explain your answer. Why is it 1,000? Because water is a liquid. And sound travels faster in liquid compared to gas, but slower than solid. Okay? Faster than air but slower than solid. Faster than gas but slower than solid.
What's that?
Iron. Thought we played this before. These iron fillings. Okay. Then this one. What is this? Particle vibrate only.
Particle vibrate.
A few seconds later, he hear his name again. Hassan stands there in the entrance. What do we call this? This thing when you can hear your voice again. This is basically echo, right? So what happens, because the sound wave what's the sound wave? Trying to continue is what?
Vibrate.
What happened? Actually, when echo, it basically means that when you produce a sound, then the sound returns back to you, right? So what do we call that? Go and then it goes back. It's like reflected. Reflect. Fleck. The sound wave is reflected back, producing an echo or something like that. Okay. Yeah, we continue with the notes. Okay, with the lesson. We don't need to do this question anymore. We just continue with the lesson. Okay. So last week we stopped at tectonics. The one I printed out for you one already is already written the blanks because last week you didn't come, right? So if I give you the blank one, then you cannot copy the previous one that we cover. So you don't need to copy anything. Okay? Okay. Tectonics. Oi. Nafa. Okay. Let's start. Okay, so last week we learned about sound wave and then about the moon also, right? We learned about the theory how the moon exists, right? And then about the nebula. Do you still remember what's nebula? What is nebula? You learned about nebula before? Nebula is basically clouds of dust and gas in space. It looks very colorful. Okay, and then this is where new stars are born. Okay, and then we learned about the Orion Nebula, Tarantula Nebula. We learned about the stellar nurseries. We watched some videos as well. Okay, so today we're going to cover about tectonics or tectonic plates. You heard about tectonic plates? What is it? Apa itu? Apa itu tectonic
I
plate?
think the tectonic plates to form the mountains or whatever.
Okay, it has something to do with like production of mountains. Okay, so basically if you remember the structure of our planet, we have like the core, right? And then we have the inner core, outer core, then we have like the mantle, then we have the crust. Okay, so the crust is made out of these tectonic plates, okay? Our crust is resting in a liquid known as the mantle. So the mantle part is actually liquid. So that's why our crust layer can move. Okay, there are convection currents in the mantle which move the tectonic plate a little bit only. Okay, so it varies between 0.6 to 1 cm per year. So that's how you get like the earthquake and stuff. Right, because of the movement of the tectonic plates. Okay, very easy. Okay, sudah copy ya. Okay.
What?
Cepat ah. Cepat ah. Cepat ah. Okay. How do we know tectonic plates are real? Do scientists just made them up? We don't know. Okay? So continents, how they know is continents could fit together like pieces of giant jigsaw puzzle. Do you know what this means? Giant jigsaw puzzle. For example, on one side maybe the continent is like shaped like this. This is what they mean. And then coincidentally, somehow the other part will look something like this. Something like this. this is on one side, this is on the other side. Okay, so based on the evidence here, this is like the C, they can theorize that initially this one and this one fits together because of the shape, like a jigsaw puzzle. Imagine if you have a jigsaw puzzle, right? Something like this, right? Then initially it's like something like this. What will happen if it's like separated? Okay, then it will become something like, and then the other will be like this. I don't know what even I'm drawing anymore. Something like this. So because it fits in a way like in jigsaw puzzle, that's one of the evidence that it is actually previously it's linked, but now it is separated. Something like that. Okay.
So isn't continents
Huh?
like just like the countries of the
Why?
on the map? They are the lines on, right?
Yeah.
Aren't they just separating the countries between the countries?
Yeah.
So they're technically not like,
Not real.
yeah.
Yeah. But now here it it is actually showing what it looks like previously, how it connects. Okay, so it is just trying to show this is previously South America, Africa. It fits previously.
Where's Asia?
I think this Eurasia, Europe and Asia. Okay, scientists say that continental jigsaw appearance is evidence for tectonic plates. Okay, there's tectonic plates because the continents are moving on top. Okay, fossil record provides more evidence because, okay, if initially all the continents are mixed together, then you would expect animals in Africa to be also present in South America. Okay, because they found a similar type of animal in South America and Africa at the same time. For example, they found a fossil dated like 300 million years ago in Africa, but then they found the same exact organism, they found the same exact fossil in South America. Then they can theorize at one point in history they must like be connected because you can find the same type of animal. If it's already separated, then it will be hard to find. Okay, for example, you can see something in Australia, but at the same time you can also see the same type of fossil in North America. Then it is only possible if at one point they are all connected together. Right? Fossil of an organism known as Mesosaurus was found on part of Africa and South America that will fit together in the jigsaw model of the continent. Another one is 300 million year old fossil of Glossopteris can be found on Antarctica, India, Australia, Africa and South America, which is very very distant from each other. Right? Antarctica is like its own island, Australia as well, but somehow this Glossopteris is present in all those places. So it must prove that at one point all the continents are stuck together. Okay. Okay. Another evidence. Our Earth has magnetic field. You know that, right? That's why compass can work. Okay, but the magnetic field of our planet is not that static one. It can reverse suddenly also. One becomes south, one becomes north. The magnetic pole. Okay, so in the past 100 million years, it has swapped around 200 times. Scientists predict. How they know is by looking at magnetic crystals found when they like dug up some layers of rocks, they can see the direction where the magnetic crystals point towards. Okay, so this is how they know. Previously, the magnetic poles are in the different direction. Around just 780,000 years ago, the same needle will point south, but now our needle of a compass will point to north. Okay, so nothing much here.
Wait, how do they know?
Hmm?
Seven, whatever, how many goddamn years that is.
How they would do is they use these magnetic crystals, right? So based on the location that they found the magnetic crystals, they can predict how old the rock they found is. And based on the direction that the magnetic crystal point towards, then they can figure out at that time the magnetic field is different. Something like that. Something like that. Does it make sense? I think it kind of makes sense. You know?
But they knew it was pointing to south.
Based
Seven.
on the rock that they found, and the rock that they found, they know that it is from a particular year, like maybe around 1,000,000 years ago or like 700,000 years ago. They can test that one using like carbon dating and stuff. You know carbon dating? And that's a technique that scientists use to estimate accurately how old something is.
But why suddenly point to north now?
It has something to do with the movement of the magma in the mantle.
Okay.
Okay. The magnetic crystal. When the rock solidifies, scientists can use the crystal to tell the direction of Earth's magnetic field in that time. So in the middle of the rock, you can find the magnetic crystal. Okay. The magnetic crystal in rocks found in the middle of the Earth's ocean has been studied. So in this location called mid-oceanic ridges, magma is coming up from the mantle and solidifying to form new rocks. So this action pushes the continents away from each other, forming. The magnetic crystals in the mid-oceanic ridges always point to the north because current's Earth magnetic field is currently in that direction. But further from the ridges contains magnetic crystal with opposite alignment, suggesting that the rocks are older. This one is basically saying it's basically saying that
I think it's time for you to retire.
it's basically saying that I don't know how to even simplify it. It's just that's it. I think the slide needs to be improved. There should be more pictures so that you can visualize it clearer. Okay. The red part there is volcano, and the blue part there is location of earthquake. So based on this map, right, they can also predict where the tectonic plate is. If the hypothesis of moving tectonic plate was correct, then we would expect there to be more earthquake and volcanoes at the tectonic plate boundaries. This is indeed the case. And our country is like very lucky.
Why?
You can see This is Malaysia. You can see Indonesia. Indonesia is in the line of the tectonic plates boundaries. So that location will have more frequent like earthquakes and
What's the
volcanic
thing in the
eruption.
middle?
Huh?
What's the thing in the middle?
Where?
The middle.
Here. This one.
Beside Malaysia.
Malaysia here.
Beside them. Yeah, that middle thing. No, the green part.
This one.
Yeah.
This is Sabah and Sarawak, the Borneo Islands.
Why is it bigger than Malaysia itself?
Because for here the top part is Sabah and Sarawak and you have Brunei, but there's also some Indonesia part also at the bottom. So this Borneo Island is actually a combination of like 3 countries. What is this? Quiz.
Brazil. No, Brazil is around there one, right?
Brazil is not even in the map.
It's there. It's there.
It's not
It's
here.
on the left. I know it's on the
It
left.
will be like somewhere here.
Exactly, it's on the left.
Then what is this?
That's Africa.
Okay. What is this region?
Isn't that also Africa?
No. This is in Asia, but this part is quite specific one. No idea.
Russia is up there, ma. China is down here.
Where's China?
China is like this, is that part.
What here?
Around there, I think. I don't know. But China is around there. Russia is at the top one, right?
Russia is somewhere here.
Yeah.
Okay. China is somewhere here.
Yeah, that's what I said.
Yeah. Then this whole area covered is like basically Japan and Korea.
Yeah.
And this is Indonesia, Philippines.
So what is that part? Is that Mongolia or some shit?
This one.
Yeah.
This one is the Arab countries. All like Saudi Arabia and Iran, Iraq, all in this region. And this one. How about this?
Taiwan. Fucking no.
This is India. That's why this is called like the Indian Ocean. What ocean is this? The ocean that divides the two. What do we call that ocean?
I'm gonna say something and then it's not
What?
gonna be correct.
What?
No, it's not correct. It's not correct. I'm gonna
What?
say.
This guess
The Pacific is there one, right? It's not here.
Pacific and Atlantic is not present here because you don't have the other
Then
continents.
how? I only know those three. I know Indian, Pacific, and Atlantic only. Yeah.
This is the South China Sea.
No one remembers the South China Sea.
Everyone knows that.
No,
Your parents would know that.
my parents would not.
They would.
They wouldn't.
Okay, let's continue. Okay. That's the end actually of the tectonic part. Here it means like the tectonic plate shape is something like this they theorize. Okay, these are the plates basically.
I feel
Oh,
bad for
for-
Japan and Korea.
Indonesia also very bad. Something like this they theorize based on the movement, based on the jigsaw puzzle.
What always the sides of the
Mm?
continent?
Because that's where the how should I say it? That's how they are separated at. It's here because this is the boundaries of the tectonic plate. This is where the point of detachment is. So that's why you have a lot of volcanic eruptions there. Here you can see right here and here it can fit also like a jigsaw puzzle. Right?
I think they grew apart cause
Why they hate each
cause,
other?
cause global warming started. And then the water
No,
the water
this has happened like for like millions of years. There's no like global warming at that time.
how would you know?
Archaeological evidence. I don't know. Try and do 6.5. It's about tectonics. 6.5. Use the note. Do 6.5. Tectonics.
Is this correct?
Inner. No, this is wrong. Core. Core should be in the middle. It's the core.
Yeah, inner core and outer core ma. I just wrote inner and outer.
It's still wrong.
Why do?
See again. Look again. Where did you label the thing? Look at the lines, man. Look, I don't know. Or
What the hell is the mental?
I just showed you before, ma. Mantle is just below the crust. Okay, and then core must be in the middle. The inner
Outer is
core.
outer.
Yeah, outer is the outer one. Inner is the inner one.
I hate this. Wait, so the tectonic plate is mental, right?
No,
I what?
it's the crust actually. Okay, the tectonic plate is like the crust.
But resting in a
It's-
liquid known as.
Yeah,
Then why is there also the thing also? So the thing here is also a liquid. So the thing here is a liquid.
yeah, liquid.
And then here is the crust.
Mm-hmm. The crust. Yeah.
I hate this. Wait, if this is a liquid, then why don't we fall under?
What do you mean? Fall under. It's just like a floaty thing floating on top of like a swimming pool.
Picture. Where is the crust?
The crust is the most outer one. Here.
But then you
The tectonic plates are the crust actually.
you got floaty on top of the swimming pool. You can also break the floaty and then you can pour down the swimming pool one ma.
And then you have like volcano eruption. Why we don't fall? Why we don't fall? Because it's not water, it's just liquid. It's like a liquid that's very dense.
So we walk on the water.
Yeah, we're currently walking on liquid.
So basically Jesus.
Yeah. Exactly. That's what Jesus meant when he said he walked on water. Maybe. I don't know. Okay. Currently, we are doing this. Which of the layers that you label in part is made of tectonic plates? That one. The crust. Okay. That's where just now we say the tectonic plate floats on the mantle. Alright? So the crust is actually the part that is on top of the mantle. What even is this?
When we
I continue ah.
oh, I'm not done.
This is 6.5. So more than 6.5.
I still got like 5 different levels. I mean like things.
So
I still got a long way to go.
how many? Oh, there's like different stages as well.
Yeah, but like 6 different stages or something. Is the last one also thick?
Describe what has happened to the continent in the last 200 million years to move them. The continents move further apart throughout the years. I guess. Which statements are evidence for tectonic plates? Same type of fossil, volcano. Okay, 1, 2 are correct. I think number 4 should also, the fourth box also should be thick. About the magnetic crystals. The second one also right. 1, 2 and 4. It should be 1, 2 and 4.
My backbone got break.
No.
Yeah, it is.
No. Yeah, it's nothing to do. Okay. So it should be just 1, 2 and 4. Volcano and earthquake most likely to happen at the border of the tectonic plate. So that's how we know this is true. List each of this part in order from hottest to coldest. So You can guess which one is the hottest, right? Yeah, simple. Hot. Hottest. All of them look ugly.
What?
They're not hot at all.
You try ah.
They're not hot, they're ugly. B, one of these parts contain large convection currents. State which part again. Which part contains convection currents? It's in your note, man. The hottest one must be the middle one, and slowly as we go to the crust, then the crust will be the coldest one. The convection current happen at the liquid part of the earth, which is the yes, the mantle is the liquid part, so there are convection currents in the mantle.
What is convection currents?
Convection current is, you still remember you learned about 3 types of heat transfer, got conduction, convection, radiation. Convection is like the hot air goes up, the cold air goes down. But it's not just air, it's basically happening in any type of fluids. Hot air goes up, cold air goes down. It's like that lah. So there's convection currents in the mantle because the mantle is a fluid, it's liquid. Okay, then the inner core is hot. So what happens is the hot liquid will go up and the colder liquid will go down. So there's a convection current continuously happening in the mantle.
Teacher, how to do this?
Describe what has happened to this continent in the last 200 years. Okay, now previously it's like this, but now what happened? The continents are separated. Okay, just very straightforward. The continents are yeah.
Wait, what causes the convection currents?
What causes the convection currents? How would I say this? This is what I just explained just now, right? But how would we write this? So just write the inner part of the mantle is hotter. Okay, the inner part is hotter. So you have the mantle, right, and the crust here. The inner part is hotter, right? So the hotter fluid will rise up. Okay, the hotter liquid will rise up, and the colder liquid at the top will go down. That's how it works out basically. Because this thing, the inner part is hotter, so it heats up the bottom one. When something is heated up, then it will rise up. The colder one will go down. That's the convection current.
No, but it says why? What causes?
Yeah, because what causes is because the inner part of the mantle is hotter than the top part of the mantle. Mid-Atlantic Ridge. For the 6.5b number 2 the answer is somewhere around here. Mid-oceanic ridges. Magma is coming up from the mantle and solidifying to form new rocks. Because locations are coming up from the to solidify to form new rocks. Locations are coming up because locations are coming up. Because magma is actually coming up from mantle and solidifying to form new rocks. Okay, it should be like that. Most of the underwater volcanoes and earthquakes in the Antarctic occur in the mid-Atlantic ridge. Cause the tectonic plate and the moving tectonic plate. What? The note here is quite incomplete actually. Do until here only. Do until 6. Until this one, until B. The next week I think I need to find more videos for this topic. Just the word is not When's your school exam?
Random one.
You?
Exam.
When's the next one? Don't know. I thought like the same one. No, random. Is it random? No, right?
I think it's much on paper.
Oh, okay. Still a long way to go.
Go sleep. Fine, man. I have nothing to do with my life.
What are you doing,
I'm sleepy.
Which one?
Said to your
Why they
parents.
moving?
Huh?
Why they moving?
Use tectonic to suggest the reason is here. They are saying why it will push, right? Because here basically you can see the picture got line one, right? So the line here is like where the boundary of the tectonic plate is. So the magma or the magma from the mantle can come out from here. Okay, it's like the lava. So when it come out, right? What will happen is new rock will form. Okay, the magma comes up and becomes rock. So in a way, it will like start to push these two away. Okay, so imagine this is two type of they are on two different plates. This is on one plate, this is on another plate. Okay, this is like this. This is another plate, this is another plate. Then something started to come out in between the line here. Okay, so it will start to push out. So this
Isn't
is
that also forming mountains?
huh?
Like, isn't that also the process of forming mountains?
Yeah.
They push together and then.
Yeah. Okay. So the answer that you should write here is this one. Magma is coming up from the mantle and solidifying to form new rocks. Okay, this pushes the continents away from each other. Is this one? Okay, what happens? The magma come out and solidify to produce new rocks. The continents will move apart as a result. Okay, so we stop here first. Hopefully next week, people will start to come back again, so it will be better.
New Year's coming. I don't think they are coming back.
So I don't know what happened to Zenning. Are you still there?
Is that actually like morning classes for children?
Huh?
Is that actually morning classes for children?
Morning classes for children.
Yeah.
Yeah, got sometimes. Like
Like, what are the rooms there for?
on that side,
Yeah.
that's for the Cambridge one is for weekend one. That's like
That's so sad.
English classes. Got a lot of people one on Saturday.
It's really sad.
What? Why?
It's a weekend and you still have to go tuition. You're already telling your friends.
It's just 2 hours only.
You're already telling your friend. It can hang out. I cannot. I'm going tuition on Saturday.
Can I go?
Yeah.
Bye-bye.
Bye. Ning, you can go. Bye. Hello, you can go. Okay, bye.